everyone, how's it going? My name is Daryl. Welcome back to this channel. In this lessons, we will work on the design. So let's go ahead and get started. First thing first, let's go through the libraries. These are all the libraries and frameworks that we would like to import. That includes a series of functions from the Matplotlib. That includes the plot, animations. So because at the backend, we would like to continue to update the CSV to capture the live data. So at the front end, we would like to continue to plot the data by reading the CSV file. And then we need to make use of the transforms to make use of the coordinate system. And then for the aim taker, it's mainly used for the x-axis to display the time. And then for the grid spat, we need the grid spat to sectionalize the entire Matplotlib. And then we need to use the check buttons to help us to create an interactive control. We need, say, color leads because we have so many colors. Sometimes and also we need to cater this interactive control. And sometimes we want to display the moving average, and sometimes we want to we might not want to display them. So we need to randomly select the color from this color map. So we need that. And then this is for the candlestick chart. And we need spanners to read the CSV file. We need the panda T8 to help us to calculate some technical indicator or technical analysis. And we need the datetimes to do the datetime objects. And we need the maps. We need the numpy as well. So the first things that we would like to do is to, of course, to create the figures. So we need to use the ELD functions to create a figure object. And then for these figure objects, we would like to set a color for this. So we will use the hatch methods and set color methods, and then design a color for it. What color that I'm using is this for the figures. So it's more like a black color. So what I'm going to do is to just give it a hash and then print out the colors. Now we need to use this grid spat to help us to sectionalize the graph. So the graph that I would like to sectionalize, so the grid is like a 10, 6. So you could imagine there's a, let me show you the picture. So you could imagine that this is a 10, this is 10, and this is 6. So we have 10 row and 6 column. So this is to use it to help me to get a 10-6 grid, so that we can add the support for each of the grids. In total, there are 4 subplots. Let me copy that. And then for the volume over here, and MACD over here, and also RSI over here, it will take 1 row and all the columns. So let's do it at the bottom. So this is the 1 row and then all the column. against one row and then all the columns. And then for the west, that will be taken by the main chart over here. So this will be up to 7, 8, 9, 10. So up to 7. So for this one, that will up to 7. So for this one, that is an 8. And then what I wanted to do is to give a design for all the subplot. So that is SC1, SC2, SC3, and SC4. So what I'm going to do is to create a functions that allow me to give a design to all of them. So I will create a figure design and then pass it along with these list. That is a list of these axes. And then for the axis, for each of the axis, SS1, SS2, SS3, SS4, in this axis, I will give them a design. Inside these functions, the first things that I would like to set is to set up the base color against an other dark color as shown here. And then I would like to stack up the take parameters for both axes, and then for the label size, that is up to 14. And then let me show you the color for this one. This is a gray color or a light gray color to display the label. And then I do not want to have the scientific notations. So here's the take label format for the use offset equals to false. By default, is equals to true. And then for the border, for the spines, from bottom, top, left, right, I will also set a color to it. And here's the colors. This is a dark gray color. So if I show the result, you should see something like this. So at the back, you will have these dark color, and then for each of the subplots, it will just follow this figure design for each of the subplots. And now let's work on the x-axis and y-axis. Before we are able to do that, let's create the animate functions first. And we need to create a animations over here. Make sure. And then this is the functions, animations, and we need to provide these figure objects, and we need to provide these animate functions, and finally we need to give it a times interval. I just give it a 1, that means it's more like a 1 second for each of the plot. And then what I wanted to do is to just separate them by a main and then by a subplot, that is the subplot that is for the volume, and then a subplot for the MACD, and finally for the subplot for the RSI. And then for each subplot, I will give a design to it, and this is the design functions to it. And because this is for the main plot, I will give it a exit 1, and for the subplot, exit 2, exit 3, and then exit 4. They have some things in common. These plots have something in common, and when we are talking about the x-axis and the y-axis, and here you can see that for the y-axis over here, for the first three plot, we do not display anything, but in the last plot, sorry, for the x-axis over here, and for the x-axis over here, for the first three plot, we do not have anything over here. But in the last plot, for the RSI, we would like to show the time. On the other hand, for the y-axis over here, you can see that for the first plot, we plot the price, but for the volume, we are not going to indicate the volumes. But then for the RSI and MACD, we also show the y-axis. So we need to create a functions that allows that have some flexibility for us to tune the y-axis and x-axis labels and also their visibility. So in that case, obviously, we need a argument for y-axis that determines their visibility. And then the other one is the x-axis and determines their labels or visibility. And in here, for the first one, the y-axis, we would like to show the y-axis. So I just add the parameters y-axis visibility equals to true for the main part. But then for the x-axis label over here, I just set it equals to false. That means we do not have any x-axis labels over here. And then for the next one, that is for the volume, we are not going to show anything. So both are equals to false. Oops. Both are equals to false. But then for the MACD, similar to the main plot, we would like to show the y-axis, but for the x-axis, we're not going to show. And then for the last one, we would like to show both axes. So for this one, for the MACD, similar to the main part. And then for the last one, that is RSI, we would like to show both axes. So now we are ready to define this axis design function. And we're going to pass along with the axis, and both of them, let's set them by default as false. That means we are not going to show anything. And inside this, because this is everything inside here, because it's inside this anime functions, that means it is going to repeat to capture the data and plot out the data. So in that case, we would like to clean everything in the previous frame or in the previous plot. So we need to clear all the things. And the first things that I would like to provide here is the grid over here at the back end. Over here at the back end, the grid. You can see this is the grid at the back end. So what I wanted to do is to give us the sign to this. So enables the grid, and then the color that I would like to have is a gray color, and then line style is a strict line, solid line, only for the major line, major grid, and then for both x-axis that is a y-axis and x-axis, and then for the line width 0.3. So now we can set up the logic for the y-axis result, and then the next one is for the x-axis labels. For the first logic is that if that is equals to false, that means we want to show something. In that case, we need to call out the y-axis and then set the visibility. And in that case, I want to set the visibilities that is like equals to true, because this is y-axis that is when it comes in the arguments, if that is equals to true, it will then just set the visibility equals to true. Otherwise, what we're going to do is to just set the take positions. We're not going to whistle the y-axis. Sorry, just make sure there's no typo. And what we're going to do is to set the text positions and then put it at the very right-hand side. So this allows me to either show the price over here or just show the tick over here. Just make sure that everything is on the right-hand side. And then for the x-axis, so if that is equals to false, and I just want to make sure that the x-axis display has an empty list, there's nothing to display. Oh, sorry. For the x-axis label, if that is equals to true, and then we will give this a empty list, and then later on we will use the x-axis functions to plot out the time to it. But then for the, if just in case, if that is equals to false, what we're going to do is to give its major tick for this axis. So in that case, the ticks are, the labels or the tick is like the size equals to 10. And if I run it, and let me save the figures, and you should be able to see something like this. And now we have the design. You can see for the main part, the y-axis over here, we will show the labels. And at the same time, everything will be on the right-hand side. And similarly for the MACD, it will show the y labels on the right-hand side, and also for the RSI. But then for the volume transactions, we're not going to show anything. And at the bottoms, at this over here for the RSI, we are going to show the time. But for all the other parts, we are not going to use the x-axis. So that's it for these videos. And then in the next lessons, we will work on the main plot. So see you in the next video. Bye bye.